After reading this problem, what you should realize is that we are given the price demand function for a revenue function, and we want to find the marginal revenue. The first way to attack this problem is to remember what is a revenue function. So a revenue function is always the price times the quantity. The quantity variable here is x, and the price is given to you by the price demand function p. So to find the revenue function, here we're going to have x times 73 e to the negative 0.000025x. 4 zeros in there. So that's our price times our quantity. To find the marginal revenue, you want to find the derivative of the revenue. To do that, what we're going to need to do is the product rule. If you remember, the product rule is the first times the derivative of the second plus the second times the derivative of the first. So we need to look at these functions individually. X being the first function, 73 e to the negative 0.000025x being the second function. So let's look at those functions and their derivatives individually. So what we have here, the first function is x. The derivative of x is quite simply 1. The second function, which is 73 e to the 0.000025x, the derivative of that you copy and paste, and then you need to remember the derivative of the exponent. So the derivative of the exponent right here, since it's just a constant times x, is quite simply that constant, which is negative 0.000025. So what I'm going to do now is use my calculator to multiply these two constants and simplify this term. What I end up with after using my calculator is negative 0.001825 e to the negative 0.000025x. So this is my first function. I'm going to multiply that times the derivative of the second plus the second function times the derivative of the first. I'm going to go ahead and lay out the product rule now. Laying out the product rule, I have the first times the derivative of the second plus the second times the derivative of the first. In simplifying that, all I'm noticing here that I can do is quite potentially pull out the common e to the negative 0.000025x. This is just a simplification measure. Technically, I could throw it in the denominator because it is a negative exponent, but I don't expect that in my class, so I would just have e to the negative 0.000025x times whatever remains. Whatever remains in the first term is negative 0.001825x, plus what remains in the second term would simply be 73. This would be my marginal revenue function and the final answer to the problem.